Of these questions, these more combination problems, is almost always finding the total resistance. So we've got a combination situation here, and so your total resistance is almost the most important, I mean, totally 100% the most important thing. So if you think about this, if you analyze this particular cell, the only parallel circuit is over here. So the resistance of this circuit, the goal is to get it to turn it into being a series circuit. So you can just 1 + 1 + 1 or whatever, right? Or whatever. So the resistance of that is 1 over 1500 plus 1 over 1500, right? And then everything else just is additive. So plus 100 is in series plus 150. And then you can then find the total resistance. And that is kind of like the most important number, because once you find the total resistance, you can then find the total current. So even though maybe these are in a weird order, start by finding the total resistance and then total current. You know, and that's just super easy. You'll just do V equals IR, because you know the voltage is 100 volts, and the resistance you're going to get from here, and this can find the total resistance. Now, when you're trying to find like the different currents, let's talk about the currents. It's important to understand that the current in the series portion of the circuit, so through here, this is the series portion, through here, the total current is the total current. So for all intents and purposes, IT equals I1 equals I4. They're all going to be the same. But when the electrons get to this part right here, they're going to split, and they're going to go make a choice and go one place or the other. And to find that, what you need to realize is that the total voltage in a combination circuit is additive. So the second thing I would do, once you know all this, is I would find in this one, I would find V1 and I would find V4. Because voltage in a series circuit drops, in a parallel circuit it remains constant. But there's 100 volts in the system, so once you know the total current, which is technically let's just do I1. So the total voltage would be equal to I1, but remember I1 is actually I total times 100, because the resistance is 100, and that will give you V1. And the same thing for this one, you would say I4, but again, I4 is total I times 150. And that gives you some numbers. These will add up to less than 100. So I'm not going to, I have the answer, but I'm not going to give it to you. Let's say, for the sake of argument, this is 30 and this is 40. Well, they add up to 70, right? Again, that's not the answer. That means that the voltage through this circuit here, through the parallel portion of the circuit, the voltage would be 100 minus 70, which of course would be 30. But that means that the voltage through both lines would be 30 volts. Again, that's not the real number. I'm just making that up. So once you know that, what you can do to find what is the current in each branch, the current would be, V equals IR. If the voltage is 30, which it is not, equals I times, in this case, 1500. And they would be both. And as a side note, this is actually a super easy problem. So once you know the total current right here, because these two are the same resistance, 15 and 1500, it will just split in half. But you would get the same result if you just take your voltage, whatever that might be, by subtracting, right? Because to find V2, V total would be 100 minus V1 minus V4. No, pardon me, I did that right. I would say V total equals V1 plus V4 plus V, now watch how I say this, I'm going to call this V23, because this will be just one voltage. Once you know V1 and V4, you can find V23. Got it? And so when I ask what is V2, V2 equals V23, if you will, and V3 is V23. That's the voltage in that portion. And then you work it all out. I mean, and then you just have to kind of, this is a puzzle that you're going to have to solve by working through each of these as you do it. Okay? I think that helps you. Bye.